Welcome back. Today we're going to be working on a confidence interval for paired data. So with this, we have looked at this type of data for the last several videos, and we've found that it's very similar to one quantitative variable when the differences are finally calculated. So with this, when we use the Fred method, we'll have the same things that we need to do. So for formulating the problem, we'll state the population, the sample, the variables, and then our parameter of interest, which for these problems is going to be mu sub d. Now we've practiced that in the hypothesis testing video, so I'm not going to go over that here. We also have reviewed conditions where we said that we need to have data that's fairly symmetric and not greatly skewed and few outliers given the size of the data set. So a larger sample size can handle more outliers, smaller sample sizes can handle fewer outliers. So then when you execute calculations, so this is the part that's going to be new, but not new. So here, remember our generic formula for a confidence interval is a sample estimate plus or minus a margin of error. So the sample estimate that we're dealing with right now is x bar sub d, and remember that's just the mean of the sample mean differences. And then our margin of error is going to be the same calculation that we used when we did a confidence interval for just plain mu, but now remember it's in the context of differences. So we'll do plus or minus, and then it's still a t star, and it's times our standard error, which is similar to what we've had in the past. It's just, again, in the context of differences, so we add the subscript d. So that will be calculating our confidence interval and executing those calculations. And then here, when we talk about our drawing conclusions, we still will have those three things. So we'll have our confidence level, so 95, 99, 90%, and then we will state the parameter. And for this one, just like we did with the hypothesis test, we'll do it in a little bit different order than just the straight parameter, just so it's easier to read that sentence. And then we'll state the confidence interval itself. Got it? So that is our generic Fred. Now we're going to do one example of the Fred. So this is the data that we looked at for a two-tailed test with the last hypothesis test that we did for paired data. So we're looking at before and after weights for sun-up dieters. So if we start with the F, we're going to say that our population is all sun-up dieters. And then our sample is going to be 10 sun-up dieters. And then our variables are going to be before and after weights. And we know that this is repeated measurements because it's taken on the same person across time. And then if we were to define our mu sub d, we always start with mean, difference, between, and then we state our variables. So between, before, and after weights, and then we state our population. So here it would be for sun-up dieters. And then these calculations are, whoopsie-daisies, taken after minus before, and so we would say difference equals, and I'm just going to shorten it to A minus B. All right, reviewing conditions. We can see that these are fairly symmetric. There's no obvious outliers. So I would just say conditions reviewed. So normally we would have a whole histogram or a box plot so that you could see if those conditions are met. But for this one, it did state in that last problem that we know this data is normally distributed. So we're just going to say my conditions are met. Now for executing the calculations. So I have all of these differences And remember that when you want to calculate these, I already have these entered in, but we have -2, -4, -7, -3, +3, -4, -4, 2, -11, and 2. So you just take the difference column and enter that into your calculator. Now, because that was in my second column, I'm just going to tell my calculator that. In the newer ones, it asks. And so my x bar sub d is 3.2 and s sub d is 4.02. So I'm just going to write that out. I have 3.2, and then we'll need our t star. And then S sub d was 4.02. So to calculate standard error, I'm going to do that. Oops, daisies. I know that that's 10. So I have 4.02 divided by the square root. Get it together. There we go. So our standard error is 1.27. All right, then we need our t star. And remember, to find your t star, you want to know how confident and your degrees of freedom. Well, we're doing a 95% confidence interval, and we have 9 degrees of freedom. So you can see here, I'm just going to zoom in a little bit. You can see here at 9 and 95, our multiplier is 2.26. So I'm going to use that. So now to get my margin of error, remember that's the t star times standard error to get you the margin of error. So we'll have 2.26 times 1.27, and that gives me a margin of error equal to 2.87. So then I'm just going to move over here. To get my confidence interval, all I have to do is add and subtract the margin of error to my x bar sub d. So I have 3.2 minus 2.87 and 3.2 plus 2.87. So my interval ends up being 6.33 up to 6.07. Okay. Now, that's easy. That's repeat from what we've done in the past. Now, a couple of things. Before I make this interpretation, actually, I'll make the interpretation and then we can talk about what we're seeing. So I'm going to switch to a different marker. So we would start by how confident we are. So we would say we are 95% confident. Let's see. Because of the order, we did after minus before, and did I come up with a negative test statistic? Or excuse me, a negative. It was negative. Silly billies. This is why, this is okay. I like having this kind of stuff happen because I messed up that it was negative and I didn't include the negative. So if I were to do that, so that was subtle. I have negative 3.2 minus 2.87, and that gives me an interval of negative 0.67, and then I'm going to do plus, so that gives me negative 0.33. Okay, so this is going to be a little bit more complicated. So here, when we do this, we are going to start with the variable that was coming in first. So we're going to start with after. So we're 95% confident the after weights are between. So now we're going to state the interval, and then after we state the interval, we'll state the rest of the parameters. So the after weights are between 0.33 and 6.07 lbs less than. Now, I did less than because here it was negative, and I don't want to interpret it as a negative. So essentially, I did take this positive interval, but then instead of saying more than, which I would have if it was positive, I said less than, and that deals with the negative sign. So less than the before weights for sun-up dieters on average. Okay, so here you can see I have my two variables, so that's part of the parameters, so before and after. I have my population, so that's the 4 sun-up dieters. On average is the term mean. So I've dealt with, that's my interval, or excuse me, that's my parameter. So then the other thing we always need is how confident we are, and then we also need the interval itself. So this one for y'all, where it's going to have some confusing aspects, is less than or greater than. Now, if you have a positive interval, you would say more than. If you have a negative interval, you would say less than. But you always want to state the numeric values as positive, and then just adjust the sign based on saying less than or more than. Now, the other thing about this data is if 0 is not included in the interval, is not included. That means you have an interval that's either all positive or all negative. Okay? If it's not included, you are able to say that there's evidence of a difference. Okay? So if 0, so 0 is the number you're interested in, if it's not included in the confidence interval, you're able to say there is a difference. However, if you have 0 included, so if, you're not going to be able to see that. Hold on. If 0 is included, so that means it ranges from a positive to a negative, or negative to a positive, negative to positive, so it overlaps 0. You would say there's no evidence of a difference, okay? So that is an important part, and that's one thing that is different from the confidence interval that we did for mu. Here, you're able to also talk about whether or not there's a difference. So 0 means no difference. So if 0 is not included in the confidence interval, that means that there is evidence of a difference. If 0 is included, meaning that the interval ranges from a negative to a positive, there's evidence that there's no difference because numerically it could be 0. All right, that's all we have for paired data. See you in future videos.